Hello again, Algebra 2 friends. So this is the second half of the 6.4 lesson. It's part 2. And we're going to continue talking about rational exponents, but more specifically how they relate to radicals and how we can kind of go between the two different forms. So, turns out my brain does not understand rational exponents very well. Like when I say, something to the 7/3 power, I don't really know what that means. Like I know it's a little more than 2. So it's like a little more than to the second power, but other than that, I have a hard time simplifying. My brain can definitely simplify radicals better, believe it or not. So hopefully in class, we've given you a chart. And if for some reason we're not in class, I would have sent you a PDF of this chart that explains, your perfect squares, cubes, fourths, and fifths, and how to go backwards and find like the square root and the cube root and the fourth root and the fifth root and so on and so on. There is a huge component to the SAT test that is on the no calculator test that loves these questions. So some of them should be kind of memorized, but for Algebra 2, we're just going to be using that chart for now while we familiarize ourselves with those properties. Okay, so first some vocab. And I stole this off the internet, of course. We have a radical sign, and then in the corner here, this is called the index. So it tells you what kind of root you have, because we know we have square roots and cube roots and fourth roots and fifth roots and so on and so on. You don't have something called a first root, because that doesn't exist. And you wouldn't have negative roots, because that would be weird too. At least not in Algebra 2. So if there's no number in the index, we assume it means it's a square root, because that is the lowest version of an index that you can have. Inside the radical symbol or the radical sign, you have what's called a radicand, and sometimes they call it a base. This radical form is something that our brains kind of understand better, but turns out you can change the radical form to a rational exponent form and vice versa. I think this example shows you the best way to convert from one to the other. So whatever the index number is, that becomes the denominator of your exponent, and whatever is in the power becomes the numerator of the exponent. So the fifth root of 7 squared is the same thing as 7 to the 2/5 power. Now, flip side of that, if I had 7 to the 2/5 power and I needed to convert it to a radical, I would be able to say it's the fifth root of 7 squared. Now, to make things further complicated, because thanks math, this power, it can be in with the radicand, with the base, or it could be out of the problem completely. And you're like, why? Well, don't get bogged down on the why, one of those mathematical anomalies, right? No, it actually does have a reason why. But the idea is if you don't have a calculator and you're supposed to compute this in your brain, sometimes you want to have the flexibility to move that exponent out of the problem. Because maybe I don't know what the square root of, I'm trying to think of a weird number. I can't. But I don't know everything off the top of my head, and the bigger the number. So maybe I want to take that power out of the problem and do it at the end of the problem instead. Sorry, I blanked for a minute. All right, let's see some examples here. First, all I want you to do is take these radicals and write them as fractional exponents or rational exponents. So the radicand, or the base, is the x. And this is where it gets weird. Kids are like, what root is it? Remember, we said if there's nothing in the index, there's secretly a 2 there, because that's a square root symbol, right? So this is the power of 8 divided by 2. Hey y'all, we have a better name for 8 divided by 2, don't we? This is really x to the 4th. So yes, even today there'll be some simplification, so watch out for that. So here we have a radicand, or a base of 3. The root, or the index number, is 5, so that's the denominator of the exponent. And then the power is a 4. So this is really the same thing as 3 to the 4/5 power. Now, I know I'm the last person who should criticize handwriting. Please watch your handwriting. This exponent needs to be little. It needs to be up in the corner in the superscript position. I have kids who write like this. Like that doesn't look like an exponent, guys. Don't do that. Make sure that it looks like an exponent. So here we have a radicand, or a base number of 10. And then if I kind of keep that same coloring format, power of 4 and a root, or an index number of 4. So 4 divided by 4, better known as an uno. So this would simplify to 10 to the 1st power, or you could just go ahead and call that a 10. And then they had to throw us for a loop, and they gave us 2 different bases. Well, it works the same way, guys. You take the base of e, And then it's power divided by index, so 2 divided by 3. So it's e to the 2/3 power. And then you're going to do the same thing for the f. It's just a totally different base, so you just give it its own exponent. So remember, there is like a secret 1 right there. So f to the 1 divided by 3. We're going to keep this lesson pretty basic. We are not interested in giving you like these crazy problems. Maybe later in the future we'll talk about some really wild problems that we've seen on the SAT test. But for now, let's keep it as basic as possible. So now let's take that same property and reverse it. So I'm going to give you the rational exponent, and I want you to write it as a radical. So first thing I do is I write a radical symbol, radical sign, and I put the index number where it belongs. So remember, whatever the denominator is, that's really the type of radical you have. And notice I just did something weird. I put a 2 there. I don't actually need the 2, because if there's no number in the index, I assume it's a square root, but you know, it doesn't hurt. Now the base also happens to be a 2, or the radicand, and then the exponent is a 1. It could be as simple as that. Now, the 1, remember, could also go outside, and then I could remember that 1 as a power doesn't do anything. So maybe I just wrote down this, square root of 2, and I said, there you go, there's your radical version. Absolutely beautiful, I love it. Okay, so radical symbol, get my right colors here. The 5 indicates what kind of root I have. Now this time I do need the 5 in the index, don't lose that. And then you've got a radicand, or a base of a, and it's being raised to the 3rd power. Remember that weird rule though? You also could have written the 5th root of a, and then outside of a set of parentheses to the 3rd power. Great, don't you just love math? So they're equivalent is what I'm saying. You can write any type of the answer as long as it's equivalent. So your job is just to rewrite it as a radical, which we did. So here we have a 5th root. That's because of this guy here. Make sure you do have a 5 there. The radicand, or the base, is also a 5. And then it's being squared. So, you know, for funsies, I'm just going to put the squared outside here. If you traveled the exponent back into the problem, and it's with the 5, that's fine. And if you went further and you changed the 5 squared to a 25, I love it. That's wonderful. But don't, because it's like extra work. All right, so here we have a 4th root this time. And then your radicand, or your base, is a 4. And then we got an exponent of 1. So again, you can kind of write it off to the side here, or you can remind yourself that to the 1st power doesn't do anything. So the most simplified version of this answer would be the 4th root of 4. Easy enough, right? So let's do this without a calculator. If you're in class, we would have given you a little chart that has all the squares, cubes, fourths, fifths, and so on and so on. So my brain does not understand rational exponents. I do not know what 9 to the 3/2 power is. But if I can convert this to a radical, I can wrap my brain around it a little better. So that's what I'm going to do first. I'm going to rewrite this as the square root, because it's a denominator in your exponent of a 2. So square root. There's nothing wrong with you guys putting a 2 in the corner here, by the way. If you like to put 2 in the corner, that's fine. Of 9. And then we're going to raise it to the 3rd power. So remember how the 3rd power can either be in the radical or out of the radical? Well, this is a clear case of I don't want it in the radical, because otherwise I'd have to figure out what 9 to the 3rd power is. And I'm already kind of lost there. So now let's talk about simplifying. I know what the square root of 9 is. It's 3. And if I had a chart handy, which I should, I know what 3 to the 3rd power is. But again, I could have just figured that out. 3 to the 3rd power is a 27. So see, you can do these problems without a calculator. Oh, speaking of chart, I probably could have figured out 9 to the 3rd power, huh? I think my chart went out that big. Oh well. All right, same idea. Rational exponents like hurt my brain. I can't understand them. My brain does not think like that, but it could think like a radical. So this changes to a 5th root because of this denominator. Oops, that's a 5. Okay, and then in it is 32, and I've kind of learned my lesson about powers. I think my brain likes the powers to be outside. So memory chart, something, not a calculator though, the 5th root of 32, this is something pretty, that's a 2. So this problem really says 2 to the negative 2 power. Oh my gosh, guys, this is a problem from like 2 lessons ago. 2 to the negative 2 power, using a negative exponent rule, means to throw it to the other side of the fraction bar. So this becomes 1 over 2 squared. better known as 1/4. Oh, I love that question. And if this was on a no calculator test, the ASVAB or the half of the SAT, we definitely could have got that question right. We wouldn't have our chart with us though. We got to remember that. Alrighty, same idea, radicals. My brain only thinks in radicals. So this becomes a square root of 4 to the negative first power. Again, I think my brain prefers the power to be outside. So the square root of 4 is a 2. And if I were to raise that to a negative first power like it says here, well guys, that's easy peasy lemon squeezy. That's just a 1/2. All right, next one, square root again. And then 16 is my radicand, or my base. And once we figure that out, we're going to be raising that to the 5th power. Okay, so that's a thinker, right? The square root of 16 is a 4. And then 4 to the 5th power, oh, I think it's 1024. I don't have a calculator with me, and I'm too lazy to open up my computer one. Let's see, 4 to the 4th power, I don't know that either. 4 to the 3rd power is 64. Times another 4 is 200-ish, and then times another 4 would be almost 1,000. Yeah, okay, we're good. I think I'm good. Now, oh man, just said you need a calculator on this next section. Okay, so suck it up, Abruzzo. You got to get your calculator out. The reason we have to get our calculator out is because unless I was going to approximate it, like legit approximate it, and I would be really far off, by the way, I wouldn't be able to do these questions without technology. So, like my desktop there, guys. We're going to be typing, now this is interesting. While my brain likes radicals, my calculator it's kind of annoying to write radicals on my calculator. So this is the 4th root of 5 to the 3rd power. It's weird. I most definitely could type that in. So it was like parenthesis and then 4th root. Here's how you pull up a 4th root on your calculator as a root. You go to math and you go down here where it says x, the x root, so number 5. Now on these newer calculators, you can just fill in the index this way. So I'm going to put 4. I already forgot the problem. 5. 5 is in the radicand. And then I'm going to close my parenthesis and then raise it to the 3rd power. If you're on an older calculator, I think you have to type the 4 before you pull up the x root. And then what some of my kids do is they pull up a square root and then they just change the index, like overtype it, which I think is very clever. Oops, either way, the answer is that. And they want hundredths, so 3.34. And that was kind of annoying to type. I don't know if you guys feel that way, but I do. And if I'm annoyed by it, I can't imagine how you feel about it. My calculator actually likes fraction exponents better. So if I could quickly convert this to 5 to a fraction exponent instead of the radical, that would be 5 to the 3/4 power. I could have just typed that. Like, boom. Same answer, right? Because it's equivalent. So I'm going to write myself a little note in my notes. This is just 5 to the 3/4 power on my calculator. Either way, you get that same approximation. So I'm going to do what's easier for me. So for me, I like the fraction better for my calculator, not for my brain. All right, so this is 3 to the 4/3 power. I'm just going to type that in. So it should be more than 3 because 4/3 is bigger than 1, so it's bigger than the 1st power. See, that's about as approximation wise as I'm going to get today. 4.33. Oops, wrong thing. Beautiful, huh? And then here, I could type it in like this on my calculator, or I could type 5 to the 2/3 power. So this is less than 1, this exponent, so my answer should be coming out to something less than 5. I already forgot it. 5 to the 2/3. I know you guys in class, you're like, oh, she can't mess up this much in class. I do. I think you figured that out. All right, 2.92. Voila. All right. See what else they got for us. Oh, man. So these are fun. These are like hybrid problems, a little algebra, a little numerical piece. And they're going to change the index, so just watch out for what the index is. Have your chart handy or start memorizing some of these numbers with me, guys. So we are going to break down the fifth root of each of these terms separately. And these are all going to come out real nice. People who are not from Harlem this year, if you are from another school district, you're going to probably encounter some problems in your future where they don't simplify beautifully. There's still going to be some stuff stuck inside the radicals. We used to do that at Harlem too, but I'm going to be honest, we kind of simplified the lesson this year because we were anticipating things not going our way in the fall of 2020. I think you know why. So just keep that in mind. You might want to go and watch one of my older lessons from 6.4 part 2 where we discuss what happens when your radicals don't fully simplify. All right, so for today, they're going to fully simplify. The fifth root of 32, that's awesome. That's a 2. So it simplifies. It comes out of the radical, and it's just gone out of the radical. Totally simplified. Now think about that exponent property that we were just having with the radicals to exponents. You're supposed to take whatever this, I need another color, whatever this exponent is, and you're going to divide by the index. So I'm going to write myself a little note. Exponent divided by the index. That's going to be your new power, right? So 5 divided by 5, that's really a to the first, which you are welcome to write to the first. It's just kind of weird. And then b to the, I got 10 being divided by 5. So that becomes b to the 2. So final answer, 2ab squared. I don't know why my 2's look different. Special Abruzzo thing. Okay, here we have the cube root of x to the 6th and y to the 9th. Same idea. It's going to be exponent divided by index again. So what do we have here, guys? We got 6 divided by 3 is a 2. And then 9 divided by 3 is a 3. These are not the same base, so you don't have to do any further simplification, and that is going to be your answer. Does it kind of feel like some of these lessons are blending together now? Yeah, they're building. This is that thing in math where it accumulates to your knowledge. It's beautiful like that, right? All right, so the fourth root of 16. Careful on this one. A lot of kids think it's 4. It's the fourth root of 16, which is a 2. And then we're going to keep simplifying. Here we go. Same idea, power divided by index. So d to the first power, I'm just going to write d. And then e to the, careful, power divided by index, e to the third. And one more. F to the 20 divided by 4 is 5. And that's it. So like I said, these were extra simple because we don't have anything that didn't divide evenly. In previous years, we had done questions where they have some leftover things that get stuck in the radicals. So go find my 2019, 2018, or 2017 lesson on this if you need something a little more thorough. And this is the practice, which means it's probably your homework. So I'm not going to do any of this with you here on the video. You need to practice these. I know it seemed really, really simple as we were going through it, but it's unusual. It's weird. It's not like intuitive to your brain. So you need to practice this. Remember, practice is the glue to math. If you don't practice your skill, you have no retention, and then you can't replicate it for me, and you won't be able to extend your learning when I ask you a challenging question. All right, good luck, everybody.